Well, hey, welcome to it. Yes, my name is Rachel Kroll, and this is the job of delivering reliability. Emphasis here on the job. We call it different things depending on where you are in this industry. Maybe you're a production engineer, right? Maybe you're a site reliability engineer. Maybe you're some kind of systems engineer. We all have the same basic idea, the same job: keep stuff running. And maybe you do this now, it's highly likely if you're here, or maybe you're watching this because you want to get into this line of work. Well, let me give you a little pro tip. This industry tends to repeat itself, and so you will see these same things happen again and again. Pay attention, and you can pretend to see the future the next time it comes around. So, okay, so why am I up here then? Like, what about me? Where am I coming from? Well, okay, so production engineer is nominally my title right now, but it doesn't really define me or limit me. It's more of I need something to fit into the org chart to kind of, plug in somewhere. I do whatever needs to be done to keep things going. And you know what? That isn't always technical. Many times the best solution is in meat space, alluded to in Melita's intro there. You deal with people and you help them out directly. There's plenty of troubleshooting events and plenty of technical deep dives. And I do have some war stories coming up here later from this and some other gigs you may have read about coming up later. Before that, this is probably where a lot of people know me from. I went out on my own. I built a lot of stuff. I wrote a lot of stuff and turned it into a couple of books. And I threw some rocks at some hornets' nests, and I think you guys know which one. Before that, I had one title and I was doing the other job, some kind of developer thing. It mattered in terms of opportunities, but enough said about that. Before that, yes, I was actually a site reliability engineer. Okay. This part of my life, this was, hi, thank you for calling company name. May I have your account number, please? Yeah, well, customer support. Despite the soul-sucking life that you think the customer support might be, actually helping real people with real problems is pretty damn rewarding, right? You sort of get instant feedback. And that set the stage for my future work and things I wanted to get out of my career. Before that, well, I had about 10,000 students, 1,500 faculty and staff. There were about 50 Linux boxes by the end of it. I did this for 9 years. I had no budget, and it was just me. Now, when you're in this kind of situation, if you're in this kind of situation, I'm sorry, you will probably do like me and have a lot of awful, nasty hacks. You'll do a lot of awful things, like how can we run 2 T1s without BGP? Yeah. I probably left behind a nice mess despite trying to document it all. So if you're watching, sorry, right? First job. Before that, I ran a BBS, right? Anybody from the old school? Yeah? All right. We thought we were so cool back then, didn't we? Right? Okay, yeah, and so on, right? The point is of my career is it has lots of variety. And I've shifted around a bunch of times and worn different hats. And every time I shift, I have to figure it out. So I see other people doing this too in their careers, jumping around, and I figure we should probably talk about this. So maybe you decide you want to go somewhere else and you want to do something different. Or at least maybe you want to do the same thing but do it for somebody else. This isn't about getting that job. I'm sorry, that's some other talk, right? Not today. But this is about you, all of you, and keeping it together once you land there at the new place. So really, this is less about making the jump and more about sticking the landing. And specifically, not flipping out when you see how they do things on the inside. Because when you learn how the sausage is made, well, okay. So I want to start with the most common reaction I see, and let me just see if anybody recognizes this one. I call this everything is broken. And maybe you've seen this, right? Maybe you've thought it. Maybe you've even said it out loud, right? Hey, look at this. I hope not, because it tends to set a bad precedent. And it's hard to dig yourself out of that hole once you've shown up somewhere and done that. Because, surprise, surprise, some people don't like that kind of feedback. Yeah, if you're not familiar, this is when you show up and you see how it all runs or think how it runs and you go, man, this is all wrong. It's probably unfounded. You haven't been around quite long enough to know yet at the new gig. So instead, let's try something else. Okay, now you're talking, right? You can't say for sure that everything is broken, but everything sure is different, right? So here's what you do. Take notes, Write it all down. You can't possibly address all of this at once anyway, and yet you don't want to forget anything. So, write something down when you see something that seems completely wacky at your new gig, and you can come back to it later. And you should revisit these things later, because at some point, hopefully, things will start making sense. You'll have context for your new gig, and you'll know what is actually crazy and then what actually belongs. And then you can set to work to doing something about it. Let me tell you a story about one thing I handled this way. Yeah, so I showed up at a gig not too long ago, and I found port map running all over the place. And Chuck McManus, you're awesome, but we don't need port map right now. RStatD, stuff for NFS, weird stuff like that running on these machines, right? But these machines didn't have any NFS mounts, and nothing coming into the box, and there weren't any NFS exports, so nothing going out of the box. And I just said, okay, all right. I filed that away under, damn, that's weird, but they probably have a good reason for it, right? Well, months later, I came back to it, and it was like, no, actually, nobody knows about this. So what do you do now? Well, you gather data. My hunch, personally, was that nobody was actually using this thing. And the question is anybody actually using this thing? So I looked through the code base. I looked for places where people might be mounting things. Nothing. I talked to some of the old hands who'd been at the company for a while. Nothing. Finally, I said, OK, all right, I need to go empirical on this. I set up some sniffers, good old TCP dump, and I went looking for traffic talking to port 111 and all the other things. Nothing, right? It's like, sweet, OK, I'm sold. It's time to do this. Let's rip this thing out, but let's do it sensibly. So I talked to the chef team. Chef team are the folks who deal with network configs and things like that, and configuration for the OS and the machine. And I asked them to come up with a recipe that would allow us to set something in our roll file that would let us turn it off. And I bribed them with chocolate. And they gave me a recipe that would let us do exactly that. So I said, all right, and using a small percentage of the fleet, I turned it on, and I basically stood back and waited for things to explode. And nothing happened. Sweet. So I went to a bigger percent. Nothing. Bigger still, nothing. Click, 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 click. All the way to 100%. Nothing broke, and nobody complained. So I said, cool, let's just take out the percent conditional test and make it the norm. So you're thinking, OK, great, Rachel, why? So what? Well, I reclaimed, a tiny bit of RSS, a tiny bit of actual memory, and closed a couple of ports, listening to the network somebody might exploit someday. Well, payoff can take a while, right? Sometime later, somebody wrote some code that they were thinking really, really well-meaning here, tried to open a path in their home directory, and it wound up running everywhere. So when it got to my machines were like, no, because no NFS and no auto mount. On other machines, well, they all tried to mount that home directory. And have you ever seen what happens when thousands of machines all try to mount the same filer at the same time? Yeah, it isn't pretty, but my machine's unaffected. So, OK, why bother making a list and then checking back on it? Well, hopefully because you care. And if you don't care about these things, what are you doing here, right? You do it because it might break, and you'd rather not have to deal with it later. You do it because it's the right thing to do. And you do it because it's the principle of the thing. You might also do it because you're part of an organization that manages to recognize, appreciate, and reward people who think ahead instead of just lavishing praise on those who ride into town when things finally go bad, right? This is not a common situation. So if you're in this situation, consider yourself very lucky. OK? How about another story? This is one I call patterns. Once you've worked in this field for long enough, you'll probably start noticing some in the way the data is laid out in computers and shown on the screen. And if you can pick up enough of this, you can solve some really screwy problems and probably blow some minds. So there was a status collector process running on a bunch of machines, and it wasn't working quite right. People were complaining that it wasn't managing to upload the metrics in a reasonable amount of time, and so their graphs were missing data points. In fact, this thing was getting shut down and restarted by a watchdog process every couple of minutes because it wasn't actually managing to upload data. Well, someone on my team started looking at it, and they discovered a few things when they called me in. And they said, OK, explained everything I just told you, and they said, all right, by the way, this thing grows by about another gig of memory every 60 seconds, like on the nose. OK? And then they said, you know what? in the logs, fork is failing. And it needs that to run subprocesses. And so at that point, it's out of commission because it can't do its work. And by the way, side note, this thing knows about fork failing and returning -1. So it doesn't try to treat it as a PID later and kill -9-1. That's the other story. Now, so this program does a lot of stuff. And the question is, of course, what is it doing when it grows? My first attempt was to open 2 terminal windows. And the first one, just tail the log file. And the second one, watch the RSS. See how big it is. And just see what flies by when it grows. Yeah, I'm sorry. This thing has just way too much stuff going by. I mean, I guess technically at some subconscious level, I saw it scroll by for a couple of milliseconds. But there's no way I could have consciously been able to derive actual useful stuff from that alone. So the second attempt was, OK, let's gather some time versus the RSS, the memory information, as a kind of rudimentary log. And the idea is to figure out when it grows exactly. So at 729.01, it's this big. At 729.02, it's this big. At 729.03, it's this big, right? What happened in between these these timestamps? So you look in the log files and you say, OK, what actually ran? What was this thing doing? This time that it ran, these things ran. And the next time around, these things ran. And hey, look, these are in common. And you end up with these candidates, the only ones that occur every single time. And for whatever reason, it seemed to be network pulls. This process connects outward over the network, gets some counter, and pulls it back in. And I should mention, there was one thing I saw in the log files while I was doing this. Error getting collector, blah, 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 no more data to read. This is one of many, many, many things scrolling by in that crazy, crazy scroll. I noticed it at the time, but I had no idea if it was new or old. And you know how this thing is where you come in to debug something and like people haven't taken care of their log files, you don't know if it's new or old. It was like, OK, I'll just kind of file that away for now. So I went into the debugger. I actually broke out GDB. I said, I need to figure out who or what is making this thing grow. And I started with the assumption it was the network code. So I said, OK, I'm going to add a breakpoint so this thing will stop right before it goes into the part where it runs a network query. And then I made a note of the arguments, because this thing would get host name and port and some other stuff on that function call. And then in my other window, I still had the thing showing me the RSS. And then it would say, OK, I'm about to do this. And I said, go. And RSS wouldn't grow. And it would come back again and say, I'm about to run another network collector. And nothing, nothing, nothing. Most of them did nothing at all to the RSS. In fact, it was only one that did anything really bad. And this happened every minute when it came back around. So what I did is I noticed that it only happened when port was equal to 8080. All the other collectors and all the other ports, all the other hosts, whatever, never happened. I changed my breakpoint to only jump on port 8080. You can do conditionals and breaks, right? Isn't that cool? I didn't know you could do that. So then I let it run again. And so now all the other collectors are running all by themselves, and RSS is staying fine, just not moving at all. So I go, OK, cool. This is not the problem. But then 8080 comes back up again. And I'm watching that RSS, and I say single step, I hit enter, and bang, it grows. It's like, OK, smoking gun, right? This is our problem. So at this point, I got a great recommendation from one of my teammates. He said that you should break on the mmap right after the point that it goes into that network code so we can see what's calling for the memory. And in this case, I had to specifically add it on just this one thread, because, of course, this is a multi-threaded program. If we trap every single mmap, we're going to be here until the cows come home. So in this case, I said, OK, wait for this to break, add the breakpoint just on this thread from mmap. And eventually, we found it. We found the malloc, the memory alloc call that was calling for all the memory. Ready for this? Yeah. It was asking for 1.2 billion bytes of memory in one go. Yeah, that's more than a gig in a single request. Remember what I said about patterns? Yeah, let's look at this one again. OK, that number, 10-digit number, it's just strange. OK, it's huge. It's stupidly so. That's not the kind of strange I mean. I mean it looks like it's from like outer space. It's like completely out of place, right? It's like it's from some other planet, some other universe. It doesn't belong there. It's like, it almost looks like a phone number, right? Makes you want to call it if it was a phone number. And you'd hear like, hello, Saul Goodman, Like, I look at these things and I get this creepy crawly feeling when I look at this number. And I'm like, there's something more going on here, but I don't know what it is. What is this thing? What is this thing? And I think, OK, this is decimal. Maybe it means something in hex. Base 16, right? Go into Python. Python's the easy way to do this. Hey, Python, hex of 48, 54, 54, 50. And I'm thinking, OK, these are even stranger numbers than the first one, because they're like printable characters. They're probably letters. They're probably uppercase letters. And one of them even repeats, right? And I'm like, OK, I really need to know what letters these are. So I use the ASCII tool, and I type in the hex things, and it tells me HTTP. What the hell? I'm dead serious, right? It was interpreting HTTP as a number. I kept a screenshot of this because who's going to believe this? Yeah. So there's the malloc, right? There's me converting it to hex, and then printable ASCII characters, and HTTP. Now, OK, a couple of my teammates were watching over my shoulder when this went on. And I'm sorry, we all just lost it and started laughing, right? And of course, everybody else on the floor was like, what's going on? And they came over, and we told them, and they started laughing. And pretty soon, the story got around inside the company, and I took this screenshot to post it internally, because, surprise, surprise, we use Facebook internally. And everybody else saw it, and people loved it. And you may have seen this post. You may have seen this post and said, I wonder where that came from. Well, now you know. So now we know the what, right? Mallocing HTTP. Now we need to know the why, right? When you're troubleshooting like this, you can't just say, OK, it did that. Well, why did it do that? Well, so you look at the source code, and it turns out this is some binary protocol stuff. It figures, OK, I need to create a buffer to handle the response to whatever query I just sent out. And unfortunately, in this particular protocol, the first 4 bytes of the response is defined as the length. So it says, sweet, I'll just make a buffer that big. Unfortunately, it's ridiculously huge and ultimately creates our problem. OK, so then the question is, where is it getting the string from? Who's actually responding that way? Remember when I said port 8080? Yeah, so it was connecting to port 8080, and it was sending this binary blob out for its request. The problem is the thing actually on port 8080 was Nginx, just a plain old web server. And port Nginx is like, I have no idea what you're talking about. And so, of course, it responds the only way it knows how. HTTP 1.1 400 byte request. Yeah. So that explains the source of the HTTP. Ultimately, this was a configuration error. Somebody pointed it at port 8080 instead of some other port, looking for metrics. And the program should have, of course, never tried to grab that much memory. But we're not done here yet. Remember that thing I mentioned about no more data to read? Right? Remember this? Yeah, this actually meant something. This actually meant, hey, you know what? I'm looking for 1.2 billion bytes of data, and that meanie Nginx only gave me like 120 or whatever it was. So I'm going to throw an exception, and I'm going to leave a mess for you. Merry Christmas. I had skipped over it before because it didn't seem connected. You see all this log spew. It's like, it doesn't mean anything, right? Yeah, oh yeah, it was staring me in the face the whole time. I just had missed it. So what can we do to make this sort of error message logging better? Well, how about if we say what we were expecting and say what we got? It would look like this. Imagine if it had expected that it said that it expected that magic number right there in the log, right? That crazy 10-digit 1213 blah blah blah. I probably would have gotten my creepy crawly feeling like, ooh, what is this number? Just from that alone. And instead of having to whip out GDB and the debugger and set the breakpoints and single step things and watch the RSS in the background and trapping an mmap and getting a backtrace and all that yak shaving, right? Just seeing the log entry would have let me say, you know what? Let's go in the source code and go find the thing that logs that error getting counter for collector, no more data to read. And looking above and below the source, that line of source, I probably would have spotted the thing that says, you know what? Let's take the first 4 bytes and malloc that for my buffer. And it would have just jumped right out as being a bad idea in that situation. And of course, the rest follows naturally. Like, don't do that. So right away, of course, the workaround was, ow, 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 ow. Don't do that. Don't talk to port 8080. So the program stopped growing, and it stopped hitting this limiter, and it stopped dying, and stopped, failing and being restarted. It actually managed to upload all of its metrics, and the graphs filled back in. Now, I'm happy to report that as soon as I reported this, the folks who owned this network code jumped on it and added some sanity checks to keep it from trying to malloc 1.3 gigs of RAM. And they also changed their logging to add exactly that sort of expected this, got that thing in case it should happen again. So if you find yourself writing code somewhere and you're looking for something and you get something else and you're going to log something about it, please consider saying what you wanted and what you actually got. You may save yourself years down the road. You can consider it a form of documentation. So that's that. As long as we're talking about documentation, let's just kind of go right into something else you should think about in your new gig. This is explaining all of the weird stuff that you encounter. So maybe you're new at a company, or maybe you're just new in a department or an area, and you're surrounded by strange, wonderful things. Hopefully you're writing some of them down so you can reassess them later because, again, remember that first part about, hey, that's broken versus that's different. There's some more value you can actually get from a list like this. You can share some of it with other people to reduce the surprise somewhat that someone else will encounter later. Remember, hopefully you will not be the last new person on that team. Hopefully. Some of this should be useful to somebody else. But you, however, are only new once. And eventually, you're going to be one of the old hands at whatever it is that your team does. And this stuff won't seem surprising. And you won't be able to emphasize with the new people nearly as easily. So don't waste this opportunity. Make the most of it and capture everything that you trip over. Because the old-timers in your organization, the old-timers know where all the bodies are buried, right? And you are going to trip over every single one of them. So you might as well make a map of them and say, while you're at it. So as long as you're asking questions, you're going to have to ask questions to understand these things. And that's when you start discovering something that I call the tribal knowledge. Have you ever seen this? This is where you have people dropping acronyms and project code names and all sorts of other secret sauce that only people inside the company might know. And they have no regard for the new person in the room. Well, maybe you're the new person this time around. You are going to have to ask what these things mean for multiple reasons. The first would be your own edification. How can you possibly understand where a team is going if you don't know the lingo? Next would be for the other people in the room. Some of the other people in the room also don't know what it means, and there's something that's going to keep them from asking. We don't know what. Please don't be that person. Pipe up and be that person to say, hey, what is this thing? I don't know what this thing is. Asking the question also serves a purpose, which is that the people who are talking about it are then reminded that they need to know their audience, and they need to speak to their audience and adapt to it. So I've actually done this at several jobs now, and the Tribal Song of the Ancestors is the name given to me by someone at that first place, hi Kevin, where I did this. And they're usually wiki pages, but not always. If you do have a wiki internally, great. If you don't, well, try to find something else that allows you to do relatively lightweight and quick edits for anyone to edit. And this is the key. You cannot keep a death grip on editing these documents, okay? You have to open it up to the world, or at least your organization. You are going to get things wrong, and other people are going to need to fix it. And of course, this being crazy industry, things are going to change, and the documentation will need to be revised at some point. This is what we call progress. And also, at some point, you won't be the new person anymore, and you won't have that much to add. Someone else will have to take it over. While you're doing this, I would just warn you of one thing. Beware the grand unified documentation model trap. You're going, okay, what is that? Have you ever had somebody come up to you and say, we're going to take all the docs in this company because they're so crazy, and we're going to cram them all into this new thing. I came up with this great ordering scheme, this great schema. They're all going to slot in here. It's going to be great. And then they start doing it, and it's like, that doesn't quite fit, that doesn't quite fit, that doesn't quite fit, right? Well, okay, well, what's the alternative, you say? Well, just let it grow. Just let it be organic. A wiki is great for this. Once in a while, some part of the wiki will stop making sense, and someone will have to drop in and do some ninja or commando edits to sort of fix just that little part of the wiki. And then they'll move on to whatever they're actually supposed to be doing. If you are that person and you try to go much beyond that, you will get bored. And then it will become yet another half-baked grand unified documentation project. The web itself actually proves that you can survive this, because the whole world every day is doing a much bigger form of this and has been doing it for a couple of decades now. And yet, it's still possible to find useful information online despite the volume and the velocity. Think of all the Tumblr pages that have come and gone, the Yahoo and the GeoCities and everything else, people renaming things, changing domains, changing extensions. Today it's Flash, tomorrow it isn't, right? And yet we still find things. How do we find things? Well, search, right? Now, this is a hard problem too. You have to get all of these systems exposed in such a way that a suitable crawler can find it. And this is on your intranet, right? Then you have to put a front end onto it so that the people can actually go in to look in that index and use it. But once you've done that, you've now opened the door for all of your people to go out there and do their own documentation without being bogged down in process. And I think we know, you work with developers, right? If you want to get documentation out of developers, you have to make it as easy as possible. I'm guessing most of them would probably rather be coding. So if you see someone in your company trying to start up another one of these solution to everything documentation systems, push back, right? And incidentally, I think there's a rumor going around that you can tell the age of a company just by counting the number of half-baked intranet documentation systems. It's the corporate equivalent of counting rings on a tree. So, OK, how about another war story? This one is about logging things that you expect, so it's kind of like documentation, like we were just talking about. It's also about helping people that you might not actually have direct access to. These are about machines that I never had access to and still don't. A friend had access, and you know what? I really actually did not want access to this group of machines because once you have those permissions, they expect you to keep fixing them, right? But I wanted to help out the team anyway, and he was having some really scary problems with them. He had reported that a bunch of his machines had rebooted right after they had started applying some change. And fortunately, these machines log over the network, so we were able to catch a couple of the messages which had sort of escaped from the machines right before they tanked. And one of them was a init saying, hey, I caught an abort, and I'm dumping core. Well, considering that a init is PID1, and it absolutely has to be there, it's no surprise that when a init goes down, the kernel panics, and the whole box goes down. But the thing is, he had caught another line in log file too, and that is the one that turned out to be useful. So right before init died, it sent out this message about why it was killing itself, thankfully. And it had the good sense to tell us what function it was in, and what line number it was in, and even a little bit about what it was looking for. Now, it didn't tell us what it actually got, but it's a pretty good guess that it would be some kind of negative number, given that it's looking for what, greater than or equal to 0. Now, this was the key, but it took some digging to figure out what this really meant. So first, I had to know that the boxes in question were running CentOS 6. And so init is not the old school sysv init that, on our beloved Slackware machines and stuff like this. And it's not systemd either. Don't throw any rocks. Yeah. It's actually from something called upstart. And it took some reading through the docs for upstart and the code of upstart to understand, like, why is this popping up here? Where is this message even coming from? And eventually, it became clear. Upstart has this feature where it will monitor paths in Etsy and under Etsy for config changes, right? No more of this edit a file and then initq or kill-11 or whatever you've had to do to goose your init to make it load files. It uses this library called libnih. Yes, really, it is called lib, like not invented here. And that library uses this kernel interface, a Linux kernel interface called inotify. And inotify works by having the client open a socket into the kernel, and then the client registers for file system changes it wants to hear about. Now, the kernel part in this is pretty simple. It just takes a C structure and fires it down the socket at the client when something happens in the file system. So this structure happens to contain a few fields, and WD is one of them. That's the watch descriptor. This is just an opaque number that you get back from the kernel when you register for, you make a request, basically, for it to watch something for you. So you say, OK, kernel, I want to know when files change in /temp. And it hands back 4. OK, guaranteed random by a dice roll. And then subsequent updates from the kernel regarding temp would have WD set to 4, and the struct it gets back from it. Easy enough. So you can say, oh, cool, this is related to the watch I set up. Well, libnih has the code to consume this, and it happens to be an nih watch handled by WD on line 202, where it has an assert that checks to make sure that WD is always greater than or equal to 0. Well, this brings us to the next point. How is WD getting outside of those bounds? It turns out it was being set to -1. Where is this -1 coming from? Well, you have to dig around in the kernel to figure this one out. And when you do, you find out the kernel has the concept of a notification overflow. OK, so what's that? Well, the socket that you use for notifications is just a buffer, just like anything else, and it can fill up. Buffers can fill up. So what happens when the kernel is like, I'm going to send you a notification, but you haven't been reading this as fast as I've been sending them to you, and I'm about to push the last one onto this buffer? Well, the kernel does this cool last-ditch effort thing where it sends you one last notification which has a bunch of placeholder data in it. And it's not really a notification about any of your watches. It's more of a meta notification, yo dog. And in this case, the watch descriptor doesn't really apply, so it sets it to -1. Well, libnih sees that, and even though it's part of init, it's like the honey badger, it don't care, and it fires that assert, and the process goes down. And of course, the kernel sees init goes down, it panics, right? And pretty soon, there goes the whole machine. Welcome to the land of reboots, population U. Yeah, well, OK, so just like many of my other stories, now we know the cause of the reboots, and even the immediate trigger. But what's behind that? Well, you have to keep asking why, right? Why? It's probably an iNotify overflow situation, but can we prove it? Of course we can prove it, right? It's a great opportunity to use a virtual machine to control the situation. So I installed CentOS 6 under QEMU, and I set to reproducing the problem. I figured, oh, cool, I can just create a bunch of files in Etsy and update them with touch, and I can generate tons of events. And then if I can spam this little VM fast enough, it should trigger the bug. So I got on the console of my machine and did exactly that. And it's easy enough to do. You create 1,000 some odd files in a directory under Etsy. You start up a whole mess of these touch instances to update the mtimes on them. And you're looking at this and you're thinking, OK, this is completely contrived. Rachel, this is a joke. Yeah, OK. So yeah, this is not what they were doing, but this is what I had to do to reproduce it. And this had to be messy enough to work, and yet simple enough to fit on a single slide, because who's going to believe that touching a bunch of files will reboot your machine? Because you have to explain this to other people later. Well, this worked great. This actually killed the box, and I got a nice panic for my trouble. You want to see what it looks like when init dies? Yeah, so if you don't speak kernelese, I know some people do, but the key parts of this are process init, PID1, and do exit. Well, init is PID1. It should never exit, never, ever, ever. It might re-exec itself if you upgrade it, but never exit. If it does, well, this is what you'll see. So I wanted to be sure that this was the actual crash that my friend had reported. And so the next thing I did was rig up syslog on this virtual machine to push messages off the VM to the parent host. That way I could see what it was saying, even though, of course, syslog D itself would go down along with the rest of the machine. And these messages would never make it to disk. And this is what I got when I sniffed it. But you can kind of see there in the red box, there's that assertion failed line. There's a init catching the abort. There's a dumping core. This is everything that my friend had reported, right? Successful reproduction. So now we can be pretty sure that something that his team was doing dropped a bunch of updates into /etc or some subdirectory that was encompassed by the watch. And the resulting influx of notifications was just too much for upstart and init and libnih to handle. And so it hit its limit. Then it got the -1, and so on and so on and so on. Remember, I never had access to these machines and had only really received 4 pieces of information about this. The machines were rebooting themselves. They were dumping 2 lines into the log, init, an assertion failed, core dump, blah. And we know it was CentOS 6. What were they doing in Etsy? I never found out. Seriously, I have no idea. I hope they were able to take this info and change the way they did things. But just in case they couldn't, I was looking out for them. I decided to create a patch to make it not crash. Now, in thinking about this, I figured maybe somebody's done the work already. I went out on the web, I did a search, and I looked for that error. And I found that back in 2011, somebody had actually reported this and had provided a patch. And the patch had been rejected, and the issue remained open. In fact, this morning, as I say this, it probably still is open. I didn't let that stop me, though, barreling on ahead here. Nothing says that you have to accept the status quo. You don't have to just sit there and take it, OK? We have the source code. We can change things. We can make things better. In particular, with libnih, for something like this, inside an organization, you can make the decision that, you know what? we're just going to say, if you overflow iNotify and Etsy, you will have undefined config update behavior for init. That's just the way it is. Well, I made that decision on behalf of the organization, and I committed us to it by changing our libnih package with just a simple local patch. It's small, it's stupid, it gets the job done. Patch is basically, hey, you know what? When we get a negative number here, if we're like running inside init, get PID is equal to 1, let's not actually kill the box. Instead, let's just log a message and say, you just dodged a bullet, and we're going on with life. Nothing dies, but you still have to fix whatever goofy thing got you there in the first place, right? But it's no longer an urgent matter. So that's the init story. I got another one for you here. I got a story about encountering some really nasty problems and being completely confused about what could have happened. And then, of course, working on it for a couple of weeks, actually, until you can understand the problem and internalize it. It's the behind-the-scenes version of maybe those of you who were here last year or watched the video may have heard. If you saw Rajesh's talk last year, he told a story about the site-wide error rate going up. And then globally, we lost a whole bunch of web servers, which then had to be rebooted. In short term, they had managed to reproduce the behavior by sending more traffic to the cluster and then distributing the latest build to it, at which point they fell over. This is all in the video, so lawyers don't freak out. They already know this. What hasn't been told yet is how we got from that to what actually happened underneath it all. So we started from a handful of hypotheses. One of them was that the kernel's killer, the out-of-memory killer, had gone mad. The supposition was something like this. When a Linux box gets in trouble and it can't allocate enough memory, this thing called the out-of-memory killer, the killer, wakes up and looks at all the processes on the box, and it picks one, it shoots it in the head. And usually that frees up enough memory to where the original allocation can now proceed, and things move on. Now, obviously, it sucks to kill processes. We never want to do that if we can help it, but what are you going to do? We wondered if maybe the killer had gotten trigger happy. The reason why we suspected an kill was almost nothing was left on the boxes when they broke. The web server was gone, SSHD was gone, and basically everything else too. So of course now you're asking, okay, how could you possibly know this if you couldn't SSH in? Easy, we logged in on the console. Init was still there, right? And it had managed to respawn a Getty, and so I could type in the root password and log in and look around. And it's like, what I saw was not pretty. It's like, well, there's init, and there's my shell, and there's this agent thing that we run on all these machines, and that's it, 3 processes. Everything else was gone. We're talking ghost town here, right? Crickets, crickets. So we started talking with the kernel developers to try to figure it out and say, hey, what's going on? And while they were doing their digging around, I started playing with it in parallel on some test machines. I want to mess with this situation. I needed to include or exclude to sort of rule in or rule out the kernel's killer. And I figured the best way to figure this out is to start taunting it. So if the kernel's killer is the bull, then I'm the idiot running around the ring trying to get it to gore me, right? It's like, come on, come and get me, come and get me. I wrote some stuff that would grab a chunk of memory, and then it would dirty the pages and mlock it so it wouldn't swap it out. And when you do this, the machine size effectively shrinks. And every time I did this, it gets smaller and smaller. And this showed me a few things, which is, first of all, even a simple loop that did, while true, date, sleep 1, done, that would block while the killer ran. Very, very strange. Now, at the same time, if I did that same memory alloc, eating memory, dirtying and locking all this stuff, the thing that grew inside a memory C group, a memcg, a container, right, it didn't lag the machine. And my date displaying loop would continue unabated. So I wasn't sure what to make of this. Like maybe it's the complexity of some big O notation thing of trying to look through every PID on the machine and figure out which one to kill. It's like, oh, that one, right? Because inside the container, it's a much, much smaller list. Or if it was something else entirely. Never figured that one out. But still, I knew this was progress. And I wrote something experimental, which would slap a memory C group limit onto our jobs so that if nothing else, while we were debugging this, at least we wouldn't have a repeat of the situation that had brought everything down in the first place. The jobs would die, but the machines would stay up. They wouldn't go and slaughter everything. So it turned out that slow killer was a tangent, right? It was just something I noticed. I mean, granted, it's a problem when the machine becomes unresponsive because it's sorting out a kill. but it was not the problem we were trying to solve here. Now, this was handled separately, and I'll just tell you, it turned out to be a mix of different things. Like, for example, when you have an killer fire, what do you usually see? That big, long list of all the stuff it's picking on, and then it picks a candidate and fires it. All this stuff about the slab info and all these things it's using. That's a lot of data, right? Well, what if you're logging over the network? You've got to generate packets to send that out. Those packets have to go into buffers. Buffers have to be allocated. Didn't we get here because we were having trouble allocating memory in the first place? That makes it slow. There's also another thing that you might not have considered. These machines have consoles. They don't have physical consoles. They have they have, BMCs. They have loopback serial devices. Yeah, a pseudo serial console. So you've got the kernel with this wad of stuff that it has to push out to dev, TTYS, whatever, at whatever baud rate, and so it's just got to block until it can get it out. Yeah, did you ever think about that? You're blocking inside of write inside of print K. The kernel hates that, but don't do that. But again, this was a tangent. The killer never killed more than one process at a time, like it's supposed to. That wasn't it. So ignoring the killer now, I tried triggering the problem some other way. I still had my test machines, so I kept playing with my little eatmem program, and it would consume memory, and I fiddled with the size of swap on the machines, because bigger, smaller. I loaded down the box, the poor little machine with tons and tons of programs, all trying to grab memory and sort of having a food fight, trying to get it to go. And that's when it happened. That's when it reproduced. Oh, shit. I think I just nuked SSHD on that box. Repro? Can it be? Hey, yep, the box is up. It is responsive at the console. No SSHD. In fact, damn near all of user space is toast. Yep. Everything on the box died just like before. And incidentally, this is the great part about working investigations on IRC. You get logs that you can go back to years later to embarrass yourself or laugh at, right? So how did I do it, you're wondering? Well, on this box, I had turned off our usual swap partition, and instead switched on just a teeny tiny little swap file. And this made it much more sensitive to memory-related stresses, and it let me trigger the problem without having to fill up this, this huge partition first. And this let me iterate quickly, because it really sucks waiting for it to finally run out of memory. And this established that it wasn't the killer. So the kernel people were off the hook. I looked in dmessage to see if the killer had fired, and instead of finding that usual dump of all that stuff, the last line was just this. It was just me turning on my little 64 meg swap file earlier in the day. And this proved it conclusively. It could not have possibly been the kernel killing the world, because it would have said something in that ring buffer that dmessage reads. Now granted, syslog-d was dead, right? There was nothing in varlog messages because syslog-d was dead, but that ring buffer would always have the latest thing from the kernel, and it was not there. So at this point, the kernel was off the hook. We let the developers breathe easier, and we could tell them, it's not you guys, it was something else. We have to go dig. At this point, I started suspecting some of our internal software. We have this thing called Tupperware that manages containers. Get it? Tupperware? And this is when I said something on IRC that turned out to be prophetic. Yeah, the thing is, to do this, Tupperware would have to essentially kill -9-1. Yeah, somewhere in my life I learned that kill -9-1 would basically do this. And a couple of minutes later, I had my smoking gun. But it wasn't from Tupperware. Remember that agent that was on the box that never went away? In the logs, this is what it had logged. Starting the kill of child -1. Like, oh my, are you serious? It's like, you're killing child -1? Like killing PID -1? What? And so I said, okay, I got to look for the code. I've got to find the source code that actually goes with this log file, right? This log message, because like, are they serious? I found it. Starting the kill of child equals curpid, right? So that's the number. -1 was in curpid. Kill 1 PID, curpid. And then that third line is from the inside of kill 1 PID, where it says kill PID sigpil. And it's like, okay, sweet. So it calls kill 1 PID and calls kill sigkill. It's running as root, by the way. Toast. So just like many of my other stories before this, now we knew who was pulling the trigger, but what clown was handing it the ammo, right? How did the -1 get from fork all the way down to the kill? Didn't something catch this in between? I looked at the source code in the repo, and it was explicitly checking the return code from fork, and it was handling it properly. It was saying -1's an error. It's like, wait, what? you just blew up and you've got the... So I said, okay, I'm really confused now. I'm staring at the code that should be the problem, but clearly it's doing the right thing. So at this point, I said, it's time to switch on history view. I want to know who's touched this code, who's been messing with this code, who wrote this thing in the first place. Well, we have something in our little fabricator tool which will show you which lines of code in a file come from which revisions. It also color codes them, so if they're really new, they're like bright green. And sure enough, that answered my question. Like 3 lines of code right under fork were bright green. They'd just been touched a couple weeks before. Now, prior to that particular change, it did have the bug where -1 was just like, cool, it wasn't an error. But the binary on the fleet had been built before the code had been fixed, and it had the bug, and it hadn't been pushed yet. Oops. So finally, at this point, we had a good and fulfilling answer to what had killed the site that day. Before this, we couldn't have been sure if it would happen again. We were sort of worried every day walking on eggshells because we hadn't gotten all the way to the bottom of it. With this, we knew we just had to push the new binary, and that would close the hole. So we did, and it did. And that's all that happened. So I have some things for you to take away from this, all of this. Please, don't freak out when you're at a new gig. Take some notes and learn, right? But remember, everything is probably not broken. It's probably just different. There's a difference. You know those weird numbers you see in log files? They probably mean something, right? Try it in alternate renderings. It might not be decimal. It might be hex. Maybe it's octal. Yeah? And if you're going to check for something in a program, say what you found and say what you were looking for. And obviously, try to document your discoveries as a new team member, but don't go overboard, right? And remember, you don't need access to a machine to troubleshoot it necessarily. A few good error messages, log file discipline, right, can let you crack a problem on a box that you can't ever SSH to. And finally, of course, fork and others can fail, and ignoring those error codes at your peril will lead to great pain someday. Well, and that's it. Thanks. So we actually have time for some Q&A. There's some microphones set up, and so, you know, I'll answer anything I possibly can that the lawyers don't tell me not to. Come on, come on, come on. Doesn't have to be about the talk. Maybe you've read some of my writing, and you're like, what really happened? Come on, Q&A, Q&A, Q&A. Anyone, anyone? If you want to ask questions afterward, you can always come find me. If there's nobody there, then you got a question?
I was wondering if you can talk a little bit about the mentors you've had in your life to reach this level of expertise.
Mentors I've had to reach this level. You know where this actually started? This started back in the early 80s with a neighbor of mine who noticed little old me tagging along with my dad, who was helping my neighbor with a computer problem. And he decided to keep me busy, and he introduced me to his stepdaughter's VIC-20. And a year or two later, he upgraded her to a Commodore 64 and came across the street and was like, here, gave me that VIC-20. And you know, you hook it up to the TV set, you have a cassette tape, and you're good to go, right? It all goes back to that. Without that, I probably wouldn't have gotten into this for years and years, and I'd probably be like running these cameras instead of like talking and working on computers all day long. Seriously, I'd be an AV nerd probably. But yeah, Flash Gordon, he passed on about a year ago, but he's like the key to all of this. Yeah, lots of other people along the way, people on IRC who will probably see this video and eventually go, hey, that was me, right? Lots of people along the way I have to thank for it. Other questions? Question.
Yeah, hi, Rick Farrow. So yeah, it seems like you've really, somehow along the way, you picked up a lot about coding as well. Because I'm going, oh, well, that was a really neat trick. She knows how to use GDB. She knows how to know. Where did you learn all this stuff? I mean, there's tricks you showed today of GDB I've never seen.
So yeah, the question is about like, where did I pick up GDB? I'm supposed to be some kind of production engineer. What am I doing touching code, right?
Right.
Yeah, so I'm just gonna tell you right now, I usually debug with printf, right? Okay, and I actually like printf and puts and this kind of stuff. That's usually how I do things. But like, I had actually built a new version of this particular program to try and troubleshoot things, and it didn't repro. Why did it not repro? Is because it was already fixed in the source tree, right? So that's why I had to go to the debugger. So the question is, how did I get into the debugger? I probably found it on Usenet back in the day, back before the Eternal September began. Somebody probably taught me about it. What year is this? What day is this in September 1993 now, right? I don't know. It came up along the way. People told me like you can use it to print variables out and like backtrace. And then of course the whole thing of like adding a breakpoint. Well, I'm sorry, I had to search the web for that one, right? Because like who knew that a breakpoint could say if port is equal to 8080? Right. Normally it's just like stop here. Yeah, I've done a bit of coding, usually in the course of solving problems for system stuff. Right? I usually am my own customer in that regard.
Sure. Hey, thank you.
Oh, thanks. Okay, well, if nobody else wants to get up here and bother me with some questions, you're not bothering me really, I guess we'll wrap it up and we'll let you go out and have some fun. So thanks for coming in and have a great day at SREcon.